Welcome to Altec Home Engineers G3 Productions.
Let's say if you have this sequence 5 plus 8 plus 11 plus 14 plus 17 plus 20 plus 23, and you want to express this series using sigma or summation notation. How would you do it? Well, the first thing you need to know is it an arithmetic or an arithmetic sequence or a geometric sequence? Notice that the common difference is 3. 5 plus 3 is 8, 8 plus 3 is 11, 11 plus 3 is 14. Because we have a common difference, this sequence therefore is arithmetic. So we need to write the general equation for this arithmetic sequence. So it's going to be an, which equals a1 plus n minus 1 times d. So the first term is equal to 5, and the common difference is 3. And so that's 5 plus 3n minus 3. So the general equation is therefore equal to 3n plus 2. So now, to express that sequence in summation notation, so first we got to draw this e, and we're going to put 1 on the bottom. And let's count how many terms we have. This is the first term. That's the second, third, fourth, fifth, sixth, 7. So we're looking for the sum of 7 terms. And then just write the equation, 3n plus 2. So that's how you can express the sum in summation notation. And if you want to find the sum, just add up the 7 numbers. 5 plus 8 plus 11 plus 14 plus 17 plus 20 plus 23. That's going to equal 98. You can also find that sum by using this equation. a1 plus an over 2 times the number of terms. So S of 7 is the first term, which is 5, plus the last term, or the 7th term, and that's 23 divided by 2 times the number of terms. So 23 plus 5 is 28, and 28 divided by 2 is 14, and 14 times 7 is indeed 98. Let's try another problem. So let's say if you have this sequence of numbers, 8 plus 4 plus 2 plus 1, and let's say it stops there. So you want to find the sum of the first 4 terms, which if we simply add it, we know it's going to be 15. But let's express it in summation notation. So notice that the common ratio is 1/2. To find the common ratio, take the second term divided by the first term. So 4 over 8 is 1/2. And just to confirm that it is a common ratio, take the third term and divide it by the second term. So 2 over 4 is also 1/2. So this is a geometric sequence. So we need to write the general equation for this geometric sequence. And this is the equation that you need. It's a1 times r raised to the n minus 1. So a1 is the first term of the sequence, which is 8. R is the common ratio, which is 1/2. And that's the general equation. So to express it in summation notation, we're going to start with 1, and we only need 4 terms, and then write the equation, 8 times 1/2 raised to the n minus 1. So you can leave it like that if you want, or you can modify it. Let's write a modified equation. 8 is the same as 2/3, and 1/2 is the same as 2 to the minus 1 raised to the n minus 1. So when you raise one exponent to another, let's say x squared raised to the third, you need to multiply the exponents. 2 times 3 is 6. So here we're going to multiply -1 by n minus 1. So then that becomes -1 times -1 is 1, and -1 times n is just minus n. So now that we have the same basis, we can now add the exponents. For example, x squared times x to the third is x to the fifth. So 3 plus 1 minus n is therefore 2 times 4 minus n. 3 plus 1 is 4. So we can write this expression as this, 2 raised to the 4 minus n, if we choose to. But now let's find another way, an equation that can give us this sum, which we know it's 15. So for a geometric sequence, you want to use this equation if it's a finite sum, meaning there's an end to it. So it's the first term times 1 minus r raised to the n over 1 minus r. The first term is 8. The common ratio, we said it's a half, but it's raised to n. And we're looking for the sum of the first 4 terms, so n is 4. Let's use brackets here. And then 1 minus r, which is also 1/2. So let's see if we can do this without a calculator. 1/2 to the 4th. So 1 to the 4th power is 1. And 2 to the 4th, 2 times 2 times 2 times 2, 4 times, that's 16. 1 minus a half is a half. So now what I would do is distribute the 8. So we have 8 minus 8 times 1 over 16, that's 8 over 16, which is 1/2. Over 1/2. Now whenever you have like this complex fraction, let's multiply top and bottom by 2. So here we have to distribute the 2. 8 times 2 is 16, and 2 times a half is 1, because the 2's cancel. And here this is also 1. So 16 minus 1 is 15, and 15 over 1 is 15, which is indeed that answer. So that equation does indeed work. But now let's say if the sequence continued. Let's say plus 1/2, plus 1/4, plus 1/8, and it just keeps on going forever. Can we find a sum of this infinite geometric sequence? And the answer is we could, but we have to use equation. We can't just add those numbers forever. But if you keep adding it, eventually you'll see that it's going to converge to a certain value. But the equation that you want to use in this case is a1 divided by 1 minus r. This only works if r is less than 1, which it is because r is a half. That's 0.5. So the first term is 8, and r is 1/2. So if we multiply top and bottom by 2, on top we have 16, on the bottom 2 times 1 is 2, and 2 times a half is 1. So 16 over 1, which is 16. So if you keep adding these numbers, it's going to converge to 16. So if you type in 8 plus 4 plus 2 plus 1, that's already 15. Then this is 0.5. 1/4 is 0.25. 1/8 is 0.125. And at this point, so far, you have 15.875. And then if you add 1 over 16, it's going to be like 15.9. If you add 1 over 32, it's going to get very close to 16 if you keep adding it forever. So if you don't know the equation, you can keep adding the numbers, and you're going to see that it's going to converge to a number, and then just round it to like an integer or something. And that's probably going to be the answer. So what about this one? 2 over 3 plus 5 over 6 plus 8 over 12 plus 11 over 24 plus 14 over 48. Now we know how to find the sum. We could just add these numbers, but how would you express this sum using summation notation? Because the challenge here is to write the equation that explains that pattern of numbers. Once we can find the equation, everything is easy. I mean, the work is pretty much done. But how do you write a general equation that explains those numbers? So let's say if you plug in 1 for n, you should get 2 over 3. If you plug in 2 for n, it gives you 5 over 6. If you plug in 3 for n, you get 8 over 12. So to do this, look at the numerators. 2, 5, 8, 11, 14. Notice that it has a common difference of 3, which means it's an arithmetic sequence. And so we can write an equation that explains those pattern of numbers using this formula. So the first term is 2, and the common difference is therefore 3. So this is going to be 3n, and then we have 2 plus negative 3, so that's negative 1. So this equation explains the numbers on the numerator. For the denominator, notice that it's a geometric sequence. 3, 6, 12, 24, 48. So to write an equation that explains that pattern of numbers is going to be a1 times r raised to the n minus 1. And that's the general equation for a geometric sequence. The first term is 3. The common ratio, we can see it's 2. 3 times 2 is 6, and 6 times 2 is 12. So therefore, to express the sum, or to express the sum using summation notation, let's see, we have 1, 2, 3, 4, 5 terms, and the numerator is 3n minus 1, and for the denominator it's 3 over, or times 2 raised to the n minus 1. So that's how we can express this sum using summation notation. Now what about this one? 3 plus negative 1 plus 1/3 plus, actually let me write it like this, 3 minus 1 plus 1/3 minus 1/9, and so forth. So notice that the common ratio, if you want to find it, divide the second term by the first term. So negative 1 divided by 3 is negative 1/3. And if you take the third term divided by the first term, you get 1/3 over negative 1, which means that's negative 1/3. So this is a geometric sequence. And so we're going to write the general equation using this formula. So the first term is 3. The common ratio is negative 1/3. And so to write the summation notation, it's going to be, let's say n is 1. And this goes on forever because there's no end to it. So we're going to use infinity. That's where it stops. And then just 3 times negative 1/3 n minus 1. Now we can reduce it because notice that we have a common base. Well, actually, no, we can't. Because 3 and negative 1/3, we could change negative 1/3 into negative 3 to the minus 1. Actually, we could change it, yeah. We could simplify it. So if we multiply these two, this becomes 1 minus n. Negative 1 times n minus 1. Now what I'm going to do is, this is positive 3, but I'm going to write it as negative 3, which is the same as positive 3. Because for me to add the exponents, these two bases have to be identical. So then it's negative, and then negative 3. Now I can add 1 plus 1, which is 2, so 2 minus n. So we can also write it this way if we want. That's another way to express the sum. So now let's find the answer to the problem. So let me rewrite the sequence. It was 3 minus 1 plus 1/3 minus 1/9. And it's an infinite geometric sequence, so we're going to use this equation to find the sum. So the first term is 3, and the common ratio is, as we said, negative 1/3. So let's multiply top and bottom by 3. So 3 times 3 is 9, and here we have 3 times 1, which is 3. The two negative signs will turn into a plus, and then 3 times 1/3 is 1, so this becomes 9/4. So we're going to stop here. That's it for this video. So that's how you can find the sum of infinite geometric sequences in series.